So 1 is potential, 2 is work. 3, PE equals mgh. 4, KE equals half mv squared. 6 is the capacity to do work, the ability to do work, some sort of word like that. 6 is gravitational, it's electromagnetic, and it's nuclear. 9's the work it can do. If you just said work, I'd give you a half. 10's a joule, 11's a scalar. 12 is potential versus kinetic. Kinetic, you want to say motion. Potential, you want to mention position, and you want to mention state. If you don't say position and say state, you'd be out at least a half from that. 16's a base level. 17, we have 4 categories: electric, which is separate in this group than magnetic, which is separate from nuclear, which is separate from gravitational. Electric, we're going to say position of charged particles in relation to each other. And then the example could be springs, batteries, chemical bonds, coal, oil, any of that kind of stuff. Just mention one. You don't have to have that whole list. Magnetic was magnets close together, like an electric motor would work. Nuclear had no definition. We're just going to say matter. Gravitational is the position above the earth. That would be something like a hammer. Anything that we lifted would work for that one. Anybody have a scoring kind of question? Yep.
The potential energy equation, do you say the P equals Fs? Because it says that in the book.
If they did one that you can, if you find it in the book and you can see that it's there, we'd give it, because I do remember they had like different versions of that. We'll want to go MGH in moving forward though. Anybody else a question about scoring? Yeah.
Can you repeat 12, 15?
12 to 15 is potential versus kinetic. Kinetic would be motion, energy due to motion. Potential is energy of position or state. And we need to say both position and state to get the full point of that.
For electric, they put the attraction of electrons.
I'm going to go half there because electrons actually repel. So, I mean, if they said position of electrons in relation to each other, I'd have taken that. Anybody else? Something scoring to 26. Okay, back to the owners they go. For next time, we'll need to read 11.6, 11.7. 11.6, 11.7 is going to have 6 new points with some very famous, well, a very famous person and a very famous equation are featured in this section that I've already previewed yesterday. But 6 total new points of, new to the quiz, maybe not new to your life, but 6 total points from the reading that feed into the quiz. Then compared to today's, from 5 down, it looks mostly like I'm keeping, but I ditched the giant question. Another small change in terms of stuff at the top. Number 1 and 2 just kind of vanishes. 3 and 4 become part of 12 to 15. So the 12 to 15 style question is not a 4-point, it's now a 6-point question. You'll name, define, and give an example. So the equations will make their way, 3 and 4 merges into 12 to 15 to make a 6-point zone. Questions, homework questions you're doing here will go 1 to 11. I have some math on the board behind me that I'll do in just a minute. But number 1 kind of feeds into the equations, so I'll just do a small run through there. The first thing is telling you that potential energy is measured by the, what was the fill-in? Potential energy is measured by the, no. Potential energy is measured by the work it could do. We have an old work equation. Our old work equation is Fs if we're talking about gravitational potential energy where we lift things, what's the force that lifts things that we're always concerned about? Yeah, the force is called yeah, but it's called an object's weight. The distance, since we're moving it this way, I guess you could call that a height. It's always been weird to me. W represents work and now W represents weight. I don't like that, but I didn't invent physics, so I have to live with it. What's our old equation for weight? mg. So what I did there is called deriving an equation. I just showed you where the science community came up with this. Potential energy measures work it could do. Work, we already had an equation. Force had an alternative name. Weight had an alternative value. But the equation you're going to want to use today in the homework for half the problems is going to be potential energy equals mgh. What's the other equation we had?
KE equals half mv squared.
Correct. So if I tell you I have a 10 kilogram thing and I lift it at 6 meters, is that kinetic energy? Is that potential energy?
Potential.
That is potential energy. Potential energy is mgh. So to figure out our potential energy, we need to take the mass in this story of 10 times g is always times the height is 6, and then we math that up, and I think that's 588. Yep. Unit for this energy is all going to be joule. Something about that. I have 10 kilograms. I've put it at 6 meters per second. Now what kind of energy is this? Kinetic, because it's in motion. Ke is half mv squared. So I need to take half the m, which was 10, times the v squared would make 36. I math that out. That's 180. And again, the unit of the day is joules. If this is a test, am I completely happy twice? Line over the zero, third significant digit, throw a bar on that zero, and then I'm completely happy. But the homework today, that's the basic concept of the 1 to 11. Now, do they maybe do some twists and turns? Maybe they do. Maybe F equals ma puts in an appearance. Maybe some sort of an old v equation. You know, maybe v equations put in an appearance. I don't know. I didn't look at it yet. We'll find out together when we look at it on Monday. But I wouldn't rule out some old v equations or some old stuff to make you work some side issues before you return. But at the heart of all the questions, there should be either one of those two equations. Yeah. Anybody, anything I can do for you? All right, cameraman, you can shut that down.